class we are going to discuss bioremediation. So the process of bioremediation will be defined as a removal of environmental pollutants. So it is a removal of environmental pollutants. So remediation we call it as removal. So the term remediation means remove. So the removal of environmental pollutants by the use of microorganisms. So it is a process of removal of environmental pollutants by microorganisms, that is called as bioremediation. So bioremediation, if you go for types of bioremediation, so types of bioremediation. So there are two categories. One is in situ bioremediation and ex situ bioremediation. In situ bioremediation and ex situ bioremediation. So coming to the in situ bioremediation, so in situ bioremediation there will be no need of removal of soil or water from the for remediation. So in situ bioremediation is the removal of environmental pollutants from soil or water. So in its place, so there is no need of removal of soil or water and take to other place for the removal of environmental pollutants. So within the same place, simply we can define as within the same place. So we can remove the pollutants within the same place. That is called as in situ bioremediation. And there are two categories of in situ bioremediation. One is intrinsic in situ bioremediation. So the process of bioremediation can be occurred by the innate capacity of microorganisms. That is called as intrinsic in situ bioremediation. So innate capacity of microorganisms which is having that is by naturally occurring microorganisms. So the microorganisms which are naturally occurring at a place, so with their innate capability or with their innate capacity which can remove the environmental pollutants within the place, that is called as intrinsic in situ bioremediation. The next one is engineered in situ bioremediation. So it is the changing of certain physico chemical properties to enhance the growth of microorganisms. So there will be certain changes, physicochemical conditions, regarding physicochemical conditions which can enhance the growth of microorganisms. Such in situ bioremediation is called as engineered in situ bioremediation. Next, going for ex situ. So it is the removal of ex situ bioremediation is the removal of pollutants, which involves the removal of water waste to a different place, that facilitates microbial degradation. So we can define ex situ bioremediation is as, so it is a process of removal of pollutants. So in this, the waste, whatever the waste, has to be moved from one place to other place, which facilitates the microbial degradation. Such remediation is called as ex situ bioremediation. Whereas in situ bioremediation is, so removing of waste and water, removing of pollutants within the same place, that is in situ bioremediation. So coming to the ex situ bioremediation, there are two stages in ex situ bioremediation. One is solid state system, or we call it as solid phase system. So which includes three methods. One is land filling, composting, and biopiles. So these are the three methods. So where we can remove, where the ex situ bioremediation can be done by using for solid waste. So first one is landfill. So landfilling is digging of land and spread as a bed over the surface. That is landfill. So whatever the contaminated soil is digged out and spread out as a bed over the surface, large surface. That is called as landfill. Next, composting is mixing of contaminated soil with organic organic elements, organic amendments. Example, man. So we have to mix the contaminated soil with organic amendments, that is called as composting. Next, biopiles. So treating of contaminated soil, treating of contaminated soil with petroleum hydrocarbons. So that is about biopiles. So whatever the solid waste, so which is taken from one place to other place and subjected to different methods. One is landfilling, composting and biopiles. So coming to the landfilling, so it is a digging of land, contaminated land, and spreading as a bed over the site. That is landfilling. And composting is, so certain organic amendments like manure is added to the contaminated soil. That is composting. Next, biopiles. So treating of contaminated soil with petroleum hydrocarbons. That is comes under the solid phase system of exitive bioremediation. Next one is slurry phase. So it is mixing of contaminated soil with water and shifted to large tanks called as bioreactors. So whatever contaminated soil is mixed with water and there is shifted to large tanks, that is bioreactors. So in which there are different methods. One is bioventing, biosparging, and bioaugmentation. Biosparging and bioaugmentation. So bioventing is use of low pressure, use of low oxygen pressure, to remove the contaminants, to degrade the contaminants. That is called as bioventing. So biosparging is also similar, but so here we use high pressure, which increases underground oxygen that degrades the contaminants. So biosparging or bioventing works with the use of low and high oxygen pressures that can degrade the contaminants. That is slurry phase. Next, bioaugmentation is frequent addition of microorganisms that can remove decontaminated decontaminated areas. So frequent addition of microorganisms. So we'll take over the contaminated area. We'll take over the contaminated area. That's called as bioaugmentation. Next, coming to the microorganisms. We use two categories. One is aerobic and other one is anaerobic. Aerobic microorganisms and anaerobic microorganisms. So certain examples includes rhodococcus, Spingomonas, Mycobacterium. So these are the examples of certain microorganisms which are involved in bioremediation. Next, factors affecting bioremediation. Factors affecting bioremediation. So there are certain factors which affects the bioremediation process, which includes nutrition availability, nutritional availability. Next, moisture content. Third one is pH values. Moisture content, pH values, and fourth one is temperature. So there are certain factors which influence the process of bioremediation. One is nutritional availability. So mostly the microorganisms that is involved in bioremediation requires inorganic material like nitrogen and phosphorus, which are required for the microorganisms to survive and to show the bioremediation process. Next, moisture content. So in order to survive for the microorganisms, there should be certain moisture content. And pH values also plays a key role in the growth of microorganisms. And finally, temperature. So temperature is of 25 to 45 degrees centigrade. So different bacteria, different microorganisms will have different temperature for their growth. So all these factors will influence the growth of microorganisms, which are involved in bioremediation process. So nutritional availability, moisture content, pH values and temperature. So this includes with the factors that affect the bioremediation. Next, advantages of bioremediation. Coming to the advantages. So the basic advantage is it is a natural process to remove the pollutants. It is a natural process to remove the pollutants, and it is of less cost. So natural process to remove the contaminants, and it is very less cost. so which includes the advantages, whereas disadvantages, which includes it is time taking process, time taking or slow process, time taking or slow process. So this comes with the disadvantage of bioremediation. So these are all about bioremediation. So we will once again revise the bioremediation. So bioremediation is the removal of environmental pollutants with the help of microorganisms. With the help of microorganisms, such process is called as bioremediation. There are two categories of bioremediation. So first one is in situ bioremediation. So it is the cleaning of waste, solid waste or water waste within the same place, within the where the waste has been produced. That is in situ hybridization, in situ bioremediation. So there is no need of removal of soil or contaminated soil or water from one place to other place. That is in situ bioremediation. It is having two categories. One is intrinsic in situ bioremediation. So it is the use of innate capacity of naturally occurring microorganisms. So in that place, so certain naturally occurring microorganisms and their innate capacity is used to remove the environmental pollutants. Such process comes under intrinsic in situ bioremediation. Next, engineered in situ bioremediation. So it is changing of certain physicochemical properties or physicochemical conditions that which enhance the growth of microorganisms in that place, so that you can act against the pollutants. That is engineered in situ bioremediation. Next, coming to the ex situ bioremediation. Ex situ bioremediation, it is the removal of pollutants. So which involves the removal of waste or wastewater or soil from one place to a different place, that facilitates the microbial degradation. That is ex situ bioremediation. So taking off waste from one place to other place and subjected to degradation. That is called as ex situ bioremediation. So there are two methods in ex situ bioremediation. One is solid phase system, which is mostly for soil contaminants, which includes landfilling, composting and biopiles. So coming to the landfilling, so digging of land and spreading as a bed, that is over the surface of the land, that is landfilling. Next, composting, so mixing of contaminated soil with certain organic amendments like manure, that is comes under composting. Next, biopiles, treating of contaminated soil with petroleum hydrocarbons, that is biopiles. So all this comes with solid phase system of ex situ bioremediation. Next, coming to the slurry phase, it is a mixing of contaminated soil with water. So I am shifted to large tanks, that is called as bioreactors. So there are three ways of treating slurry phases. One is bioventing and biosparging and bioaugmentation. So bioventing and biosparging comes with same mechanisms, so with little changes. So use of low oxygen pressure to degrade the contamination is bioventing, and use of high pressures which increases the underground oxygen pressure, that is biosparging, which degrades the contaminants. Next, coming to bioaugmentation, frequent addition of microorganisms to the tank bioreactors that can take over the contaminated area and makes the decontaminant. That is bioaugmentation. So that comes with slurry phase. So in ex situ bioremediation can be done by using solid phase if the waste is solid, and slurry phase if the waste is in liquid or semi-liquid form. That is slurry phase. Next, coming to the factors that affects the bioremediation, which includes nutritional availability. So mostly inorganic minerals such as nitrogen and phosphorus are required for the microorganisms to grow. Next, moisture content also plays an important role. pH values, so which decides the growth of microorganisms, and temperature. So these are the different factors that affects the growth of microorganisms, which ultimately involved in bioremediation. Next, coming to the advantages. So advantages, so it is a natural process which removes the contaminants and is of low cost. Next, disadvantages is it is a slow process. It is a time taking process. So this is all about bioremediation. With this we have completed the topic of bioremediation.